Okay, let's take a look at example number 6. Okay, so a limit that does not exist. This is called the Heaviside function h and is defined by the following piecewise function. When h of t is equal to 0, that means that it's a horizontal line where t is less than 0. So that means it's approaching all the way to 0, but it doesn't include 0. Okay, and then another horizontal line, h of t is equal to 1, and it starts at when t is equal to 0 and then greater than 0. So again, here is a piecewise function. Okay, now this function is named after an electrical engineer called Oliver Heaviside and can be used to describe an electric current that is switched on at time t is equal to 0. And this is the graph that's shown. So what it's saying here is that as t approaches 0 from the left, then the function h of t approaches 0. Now, as t approaches 0 from the right, then the function is approaching the value of 1. So there is no single number that h of t approaches as t approaches 0. So therefore, we would say that it does not exist. Okay, so we would say that then the limit as t approaches 0 of the function h of t, okay, it does not exist. Okay, hence, which is what we're going to talk about when we talk about one-sided limits. So now we notice from this example that h of t approaches 0 as t approaches 0 from the left, and h of t approaches 1 as t approaches 0 from the right. Now we indicate this situation symbolically by writing the following. So the limit as t approaches 0 from the left, that minus represents that it's approaching 0 from the left, which is equal to 0. And the limit as t approaches 0, the plus meaning from the right, the function is approaching 1. So again, the symbol t approaches 0 from the left indicates we consider only values of t that are less than 0. And likewise, t approaches 0 from the right indicates that we consider only values of t that are greater than 0. Okay, so this creates our new definition. Okay, our definition states the following. So we write that the limit as x approaches a from the left of f of x equals L, and we say that the left-hand limit of f of x as x approaches a, or the limit of f of x as x approaches a from the left, is equal to L if we can make the values of f of x arbitrarily close to L by taking x to be sufficiently close to a and x less than a. Now, if you notice that definition 2 differs from the definition 1 only in that we require x to be less than a. Now, similarly, if we require that x be greater than a, then we would get the right-hand limit of f of x as x approaches a is equal to L. And then how would we write that? Well, we would write that down here like the following. We would say that the limit as x approaches a from the right of f of x is equal to L. So you can see what's happening with these two graphs. So again, as x approaches a of the function from the left is equal to L, and over here, f of x is approaching a from the right is equal to L. So the definition states the following. Now, the limit, this is an important definition. As x approaches a, the function is equal to L if and only if the limit as x approaches from the left of f of x is equal to L and the limit as x approaches a from the right of f of x equals L.